Good evening, and welcome to the Song of Urania, a podcast about the history of astronomy from antiquity to the present, with new episodes every full moon. My name is Joe Antonini. Well, last month we took a bit of a detour in the overall narrative of the podcast in honor of the first blue moon this podcast has seen, at least according to one definition of blue moon. But now we're back to a normal full moon. A harvest moon specifically, so it's time to jump back into it. But before I do, I did want to issue a mea culpa. I'd actually meant to do this in the last episode, but I got so carried away with the blue moon that it slipped my mind. 2 episodes ago, in the last episode on Egyptian astronomy, I told you that the Egyptians used a ratio of 7:6 for the length of the night between the winter solstice and the summer solstice. That part was correct, but I then compared them to the Babylonians and told you that the Babylonians used a ratio of 2:1. I'm afraid that I rather threw the Babylonians under the bus here, because in fact they used the ratio 3:2, which is still way off, so my point still stands, but it isn't quite as egregiously wrong as 2:1. My apologies. With that embarrassing start out of the way, in the next few episodes we'll take a look at the astronomy of ancient India. As you may know by now, when I'm starting to learn about a civilization, I like to start with the geography of the land it inhabited, because while geography doesn't determine everything, it still determines a heck of a lot. It tells you where people tend to live, which neighbors they tend to interact with, and which neighbors they don't, what they eat, what kinds of things they can build, and on and on. And, of course, as with everywhere else, geography is important to understand India. Probably the most notable feature of Indian geography is that although it's attached to the Eurasian landmass, it's nevertheless relatively isolated from the rest of it. And in fact, the reason for this is that that's the way it was originally. What we call the Indian subcontinent was originally an isolated island landmass 100 million years ago. But thanks to the inextricable work of plate tectonics, about 55 million years ago, 10 million years after the extinction of the dinosaurs, the Indian subcontinent collided with Eurasia. This collision formed the Himalayas, and is still ongoing, pushing these mountains yet higher by about half a centimeter per year, or about half a meter per century. So certainly the most important geographical fact about India is that almost its entire northern perimeter is bounded by what is perhaps the most formidable mountain range in the world. At the eastern edge of the Himalayas, there's a gap between the Himalayas and the Bay of Bengal, but this area has a lesser mountain range called the Arakan Mountains, and it's also carpeted in dense jungle, which makes passing through it difficult. So the main point of contact between India and the rest of Eurasia has been from its northwest, though even here the route is beset by desert and highlands. The main consequence of all this is that over the centuries, India was mostly, but not completely, isolated from the other civilizations on the continent. It was safe from invasion from the north and east, but suffered from invasions from the west every now and again. Within India itself, the 2 most prominent features are, again, thanks to the Himalayas. The weather from the Indian Ocean brings moist air across the subcontinent, and when it hits the Himalayas, it rises up, condenses, and precipitates as snow. Later on, this snow melts and runs down the mountains. The runoff bifurcates, with runoff from the western range ultimately draining into the Gulf of Arabia, and the runoff from the eastern range ultimately draining into the Bay of Bengal. But in this process, they form 2 large river valleys, the Indus in the west and the Ganges in the east, which are together known as the Indo-Gangetic Plain, and form a kind of inverted V to the south of the Himalayas, with the 2 separated by the Thar Desert to the east of the Indus River Valley. Historically, the bulk of India's population and the center of power has resided in these 2 river valleys in the north of the country under the shadow of the Himalayas. The Himalayas have impacted India in other ways as well. If you look at the latitude of these river valleys, they're not quite tropical. Delhi, for instance, sits on the western edge of the plain associated with the Ganges River, and its latitude is 28 degrees, roughly the same latitude as Orlando, Florida. But India's weather tends to be far more tropical than you would expect from the latitude alone, because the Himalayas block winds from the north from bringing in cool air, and simultaneously trap moist air from the south. South of the Indo-Gangetic Plain, the terrain is more rugged, with a rocky highlands called the Deccan Plateau, which is itself surrounded by a number of lesser mountain ranges. The Vindhyas and Satpuras to the north, the Western Ghats to the west, and the Eastern Ghats to the east, the two of which nearly meet at the southern tip of the subcontinent. The main consequence of all this is that travel in the south of the country has historically been more difficult. Not impossible, just slower, so the south of the country is culturally and linguistically quite distinct from the north. But to see how these cultural and linguistic distinctions developed, we'll now have to turn to the history of the people of India itself. And here again, probably thanks to its geography that limited contact with the outside world, India is rather unique among large-scale civilizations in that in several fundamental ways, there's a strong continuity between the India of 1500 BC and the India of 2000 AD, particularly in the rural areas. There are only a couple of other large civilizations that can make a plausible claim to that kind of continuity over the millennia, with China being the other main example. By contrast, if we look at some of the civilizations we've already covered, there really isn't too much of a resemblance between the Egypt of 1500 BC with modern-day Egypt, apart from the fact that the two civilizations lived in the same spot. The language changed, the religion changed, the social structures changed, and on and on. Same with the Babylonians. Apart from living along the Tigris and Euphrates, they don't really share anything in common with modern-day Iraqis, and even here, the land that the Babylonians worked was quite different from modern-day Iraq. It was much more fertile 4,000 years ago. Modern-day Greeks at least speak the same language as their ancient forebears, but of course none of them are worshipping Zeus and Hera. But if we look back to ancient India, we see a culture that is quite recognizable to the culture of today. Now, India was first populated quite early on, probably sometime between 80,000 and 40,000 years ago, though possibly even earlier. But as with everywhere else on the globe, during the Paleolithic, these original inhabitants were hunter-gatherers. The first agricultural civilization to develop in the region formed in the Indus River Valley and has come to be called the Harappan Civilization after one of its major cities, Harappa, though it also goes by the more generic name, the Indus Valley Civilization. The Harappan civilization started to coalesce around 3300 BC, and as with the development of Egyptian civilization along the Nile, it's suspected that one of the main drivers of migration into the river valley was desiccation of the surrounding regions. The Harappans seem to have learned from their neighbors to the west in the kingdom of Elam, who in turn had learned from their western neighbors in Mesopotamia. As an aside, you may remember from the earlier episodes on Mesopotamia that to the Babylonians, Elam represented the farthest known land in the east. Nevertheless, even though the Babylonians didn't know about the Harappans and vice versa, through this kind of daisy chain, agricultural innovations in the Fertile Crescent were able to spread into India. Now, while the Harappans were happy to have learned some things from the Mesopotamians, they came up with a few tricks of their own. One of the more important of these was the invention of fired brick. The Mesopotamians built their structures out of mud bricks, which are made by mixing clay-rich earth with water to make mud, and usually adding in something like straw to help bind it together. You then form the mud into the shape you want and leave it out to dry in the sun for a few days, and then you have your brick. Now, this worked well enough for the Mesopotamians, but mud bricks have a few problems. The first is that, as far as bricks go, they're relatively brittle. But the other issue is that it really works best in hot, dry climates, where the sun can really do its work to dry it out. But the Indus Valley is somewhat more humid than the Fertile Crescent, so drying bricks in the sun was more challenging. The Harappans figured out that if they dried their bricks in an oven, not only did it solve their problem with humidity, the bricks also became much stronger as a result. This allowed them to engage in durable large-scale construction in a region that lacked stone. The Harappans really started building around 2600 BC or so, and the cities they built were really quite impressive for the Bronze Age. Harappa and Mohenjo-Daro are the two largest cities they built, and are estimated to have housed between 30,000 to 60,000 people. There was evidently also some sort of large-scale governance among the Harappans, because the cities are also remarkably well ordered. The roads were clearly planned with wide avenues and formed orderly grids. Perhaps the highest sign of the sophistication of their civilization is that on many streets, nearly every home had an indoor bathroom that connected to the municipal sanitation system. Now, unfortunately, there is quite a bit that we don't know about the Harappans, and this includes virtually everything about their astronomy. Really, there's only one thing we can say about it for certain, but before I can mention that, I'll have to talk about its decline. Harappan civilization flourished for around 600 years, and then starts to disappear around 1800 BC. The cause is not known for certain, but two major developments almost certainly contributed. The first is climate change in the region. A common problem for many river valley civilizations is that rivers carry silt from upstream and deposit it downstream. Over the centuries, this silt buildup causes the riverbed to become more shallow, which leads to more frequent flooding. So there's some evidence that floods along the Indus River became a problem for the Harappans towards the end. Along with flooding, the Harappans also seem to have caused some trouble for themselves by overlogging the surrounding forests, and this deforestation was probably exacerbated by increasing desiccation. But beyond the climate-related problems, the Harappans also had to deal with a more man-made threat, the arrival of a new people, generally referred to as the Aryans. Now, if we're being pedantic, the term Aryan isn't really an ethnic term so much as a linguistic term, in the same way that Indo-European really refers to a language family rather than a group of ethnicities. But technicalities aside, the people that show up on India's doorstep around 1750 BC are almost universally referred to as the Aryans. The Aryans are the people that largely populate modern-day India, particularly in the north. Not as much is known about the origins of the Aryans as we would like, but what is known is that they originated in Central Asia, in the southern Eurasian steppe. The Aryans were probably originally associated with the culture known as the Sintasha culture, who were located around the border between modern-day Kazakhstan and Russia. They were a pastoral people, and, at least based on the archaeological remains, quite warlike. In fact, these predecessors of the Aryans have a strong claim for being the inventors of the chariot, since the oldest known artifacts of chariots come from Sintasha sites. Well, as pastoralists, they were naturally fairly migratory, and maybe around 2000 BC or a bit later, a group of them split off and began to migrate south. During this period of migration, they passed through another culture, designated the Bactria Margiana culture, in a part of Central Asia that is modern Uzbekistan and Turkmenistan. They appear to have assimilated a few religious practices from the Bactria Margiana peoples and continued their migration. Some of them split to the west and eventually made their way all the way to Syria, where they formed the Mitanni kingdom, which was a rather obscure Mesopotamian kingdom unless you're really deep into Mesopotamian history. But the other branch of the Aryans migrated south and east, through what is modern-day Iran, Pakistan, and ultimately into India. Now, what the arrival of this wave of newcomers looked like in India is not entirely certain. We can imagine that it probably involved a lot of bloodshed, but the evidence is more circumstantial than we would like. Some scholars, for instance, pointed to the discovery of skeletons in the streets of the city of Mohenjo-Daro that appeared to have trauma, but later analysis found that these skeletons were put there long after the cities had been abandoned, and the trauma on the skulls was due to erosion rather than from battle. Some of the passages of the Rigveda, about which I'll have more to say in a bit, also describe invasion and conquest, and if you squint, it's possible that certain details may be referring to Harappan cities. But all we can say for sure is that the Harappan civilization collapsed by around 1600 BC, and around that time, the Aryans have shown up. For what it's worth, the original inhabitants don't seem to have died out entirely, and today it's believed that their descendants make up a group called the Adivasi, which in Sanskrit literally means original inhabitant. That said, the poverty and low social status of the modern-day Adivasi suggests that the people of the Harappan civilization seem to have gotten the worst end of things upon the arrival of the Aryans, because once things shook out, it was the Aryans who were on top, and early on a set of rules emerged which codified these social stratifications in what evolved into the caste system. In fact, it's in the early caste system that we see the evidence for really the only thing we can say for certain about the astronomy of the original Harappan civilization. According to the Code of Manu, which was written between the 1st and 3rd centuries AD, marriage was prohibited between an Aryan man and a woman named after a constellation, which implies that the Harappans were interested enough in astronomy that they would name their daughters after constellations. Of course, women named after constellations were by no means the only prohibitions in the Code of Manu. It also went on to forbid marriage between an Aryan man and a woman named after, quote, a tree or a river, one bearing the name of a low caste or of a mountain, or one named after a bird, a snake, or a slave, or one whose name inspires terror, end quote. Now, in terms of the metrics by which we usually judge the sophistication of ancient cultures, the arrival of the Aryans seems to have set things back quite a ways on the Indian subcontinent. The Harappans had some kind of writing, which unfortunately has not been deciphered, but once the Aryans arrived, writing disappears on the subcontinent for more than a millennium. Cities also disappeared for centuries and were much less impressive when they returned. One of the reasons that this period of Indian history is somewhat speculative, despite its importance, is that all these massive changes don't seem to have been organized in any meaningful way. This was not like a conquest by a mighty foreign empire. It seems more like a prolonged period of waves and waves of smaller bands of people, maybe comparable to the barbarian invasions that eventually overwhelmed Rome 2 millennia later. At any rate, the result of all this was that as the Aryans settled across this new land, they were quite fragmented politically. Gradually, they transitioned from the pastoralist lifestyle they brought with them from the steppes of Central Asia to agriculture, and the introduction of iron sometime during this period helped tremendously with this transition. It's not really until the middle of the first millennium BC, say 600 BC or so, that the traditional markers of civilization start to reappear. Around this time, political power starts to consolidate, but now the center of gravity is in the Ganges River Valley rather than the Indus River Valley. And, at long last, writing reemerges in the region. The most important documents from this period are the Vedas, the 4 main sacred texts of the Hindu religion. Now, Hinduism is largely the religion that the Aryans brought with them into India, but they were fairly syncretic. They adopted some of the practices of the Bactrians that they encountered on their migrations, as well as some of the practices of the native Harappans. But as with other ancient religions, its practices were transmitted orally for centuries. But although the first written versions of the Vedas appear later, there's strong evidence that they were codified much earlier. From our perspective, looking at the history of Indian astronomy, the most important of the 4 Vedas is the oldest one, called the Rigveda. The Rigveda is a collection of more than 1,000 hymns, and may have been largely composed as early as 1450 BC, though certainly it was codified by 1000 BC. Now, while the focus of the Rigveda is naturally on the religious, there are a couple of passages from which we can glean a detail or two about early Indian astronomical practices. Hymn number 103 in Book 7, usually translated as frogs, indicates the way that the Aryans marked the new year. The hymn says, quote, as Brahmins, sitting round the brimful vessel, talk at the soma rite of Atiratra, so, frogs, ye gather round the pool to honor this day of all the year, the first of rain time. These Brahmins with the soma juice, performing their year-long rite, have lifted up their voices, and these Advaryas, sweating through their kettles, come forth and show themselves, and none are hidden. They keep the 12 months' God-appointed order, and never do the men neglect the season. Soon as the rain time in the year returneth, these who were heated kettles gain their freedom. End quote. So, from this, we learned that prior to the first millennium, the Aryans had a calendar and marked the new year with the arrival of the seasonal monsoon. Now, the fact that the Aryans had a calendar isn't maybe that much of a surprise. Every culture on the planet keeps some kind of calendar. But what is perhaps somewhat surprising about this is that they decided to mark the new year with the arrival of the monsoon. Now, in some ways, this is expected. The annual monsoon in late summer was, and still is, the most important event of the agricultural year. Incidentally, if its significance reminds you of the significance of the flooding of the Nile over in Egypt, this is not a coincidence. These 2 events were due to the same overall weather pattern in the Indian Ocean. So, the arrival of the annual monsoons was a natural choice to mark the new year, just as the Egyptians tied their new year to the flooding of the Nile. But what is unusual is that the monsoon is a phenomenon of South Asia. The massive amounts of water that the monsoon dumps on the subcontinent is in part thanks to the Himalayas, which block the passage of this moist air northwards. In the homelands of the Aryans, north of the Himalayas in Central Asia, there were no monsoons. So what this means is that their original calendar must have looked different. But once they had arrived in this new land, within a relatively short period of time, they had ditched their old calendar and adopted a new one that was better suited to their new climate. Now, like most ancient civilizations, the Aryans used a lunar month, and as with all lunar calendars, there's the perpetual problem that the length of the month does not evenly divide the length of the year. So the year has about 12 months, but not quite. The Rigveda also provides evidence that the Aryans solved this problem the way that most other cultures did, with the introduction of an occasional 13th intercalary month. In the 25th hymn of Book 1, there is the line, quote, "True to his holy law, he knows the 12 moons with their progeny. He knows the moon of later birth." End quote. This moon of later birth is generally interpreted as referring to the intercalation month. Now, at least in this translation, this is a rather oblique reference, but this reading is not a new one. The interpretation of this line as referring to an intercalation month goes back at least to the commentator Sayana in the 14th century AD, who was one of the more influential commentators on the Vedas. The final hymn in the Rigveda with a direct connection to astronomy that I'll mention is hymn 85 in Book 10, verses 2 and 3. Here, the Rigveda indicates that the Aryans took special note of the constellations of the ecliptic. One of the verses in question says, quote, "By Soma are the Adityas strong, by Soma mighty is the earth. Thus Soma in the midst of all these constellations hath his place." End quote. Soma is the god of the moon, and the Aditya are the children of the goddess Aditi. So this verse describes how the moon passes through the constellations of the zodiac. Later on in the hymn, we also get the names of two of these constellations, Magha and Arjuris. Magha would have roughly corresponded to the modern constellation Leo, in particular centered around Regulus. What Arjuris was, though, I was not able to determine. The last aspect of astronomy that appears in the Rigveda is somewhat more generalized, and this is the conception of time that it presents. At the time of its composition, the Aryans recognized 6 seasons: Vasanta, which roughly corresponds to the western season of spring, Grishma, which corresponds to summer, Varsha, which is the rainy season when the monsoon arrives, followed by Sarad or Sharada, which corresponds to autumn, Hemanta, which is winter, and lastly, Shishira, which is the cool season. Then it's Vasanta once more, and the whole cycle starts all over again, although I've westernized the endpoints since they started their year in the rainy season of Varsha. This set of seasons is still recognized in India today. The other timekeeping term that has its origins in the Rigveda is the Muhurta. Now, when it first appears in the Rigveda, it has a rather general meaning, just a moment in time, without any precise duration. But in later works, in particular the Brahmanas, the term Muhurta gets a precise meaning of 1/30th of a day, or 40 minutes. Beyond these specifics, the Rigveda on the whole has a particular conception of time and how it should be demarcated. In particular, one theme that comes out of the Rigveda is the importance of divisions of time and rituals that emphasize these divisions. The Vedas speak of rituals at the full moon, the new moon, and the change of seasons. One of the commentaries on another of the 4 Vedas, the Shatapatha Brahmana, speaks poetically of the importance of marking these divisions. The commentary speaks of a story in which Prajapati, the god of creation, had in essence lost the articulation in his body after he had created the creatures of the earth. His joints were too weak to bear any weight. The commentary says, quote, "After Prajapati had created the living beings, his joints were relaxed. Now Prajapati doubtless is the year, and his joints are the 2 junctions of day and night, the full moon and the new moon, and the beginning of the seasons. He was unable to rise with his relaxed joints, and the gods healed him by means of these Havis offerings. By means of the Agnihotra, they healed that joint which consists of the 2 junctions of day and night, joined that together. By means of the full moon and the new moon sacrifice, they healed that joint between the full and new moon, and joined that together. And by means of the 3 katermasyas, which are the seasonal offerings, they healed that joint between the beginning of the seasons and joined that together. End quote. So this commentary is a window into the Hindi conception of time, with an emphasis on distinct periods joined together and marked at these times of transition by ritual and sacrifice. Well, in that spirit, I suppose now would be an appropriate time to provide a brief overview of the different phases of Indian astronomy, because I sort of ended up just jumping right into it after getting to the Aryan invasion. Traditionally, Indian astronomy is divided into 7 periods. The first is the prehistoric and Harappan period, which we already covered, and there isn't a lot to say about it. Unfortunately, we just don't know very much about the astronomy of the Harappan Civilization, apart from the fact that it was apparently common to name daughters after constellations. Perhaps if Harappan writing is ever deciphered, we will be able to say more. The second period is the Vedic period, and is what I started to get into after the Aryan invasion. The Vedic period lasts for about a millennium, starting around 1500 BC when the Aryans became settled, and ending around 500 BC. The Vedic period is in turn subdivided into 3 sub-periods. The first is the Rigvedic period, where the main source of our knowledge of their astronomy comes from the Rigveda. This lasts until 1000 BC or so, and while our understanding of this period is at least somewhat more developed than the astronomy of the Harappan period, it's still pretty patchy, since we more or less have to rely on squinting at certain passages in the Rigveda, which was not first and foremost an astronomical text. By analogy, our understanding of this period is a bit like how we can say a few things about the astronomy of the archaic period of ancient Greece, based on a couple of lines in Homer's Odyssey and Iliad. Astronomy was an important enough subject in the ancient world that any lengthy text would end up saying something on the matter, but even still, it wouldn't say much. Things really get going in ancient India around 1000 BC. And it's here that the Vedic period enters into its second subdivision, the later Vedic period. The later Vedic period lasts until about 500 BC, when it merges into the last subdivision, which is called the Vedanga period. Around this time, the astronomical record becomes much more fleshed out, and there's a lot more to say on the subject. I mentioned earlier that Hinduism has 4 sacred texts called the Vedas. These were the oldest texts, and as in other religions, as time passed, they motivated people to write commentaries or other auxiliary works to better explain the implications of their contents. By the middle of the first millennium BC, 6 additional texts became codified, called the Vedanga. If you're more familiar with the Abrahamic religions, you could maybe loosely analogize the stature of the Vedanga to that of the Talmud in Judaism. A hugely important text, and one which a serious student of the religion would spend a lot of time reading, but nevertheless one which is fundamentally auxiliary because its purpose is to help you better understand the primary text or carry out its precepts. The 6 texts of the Vedanga deal with different disciplines in the study of the Vedas. The first is the Shiksha, which literally translates to teaching, and deals with the fundamentals of reading the Vedas, quite literally by going over the letters of the alphabet, how accents work, and how to read the text melodically. The second text is the Chandas, which translates to meter, and as the name implies, explains poetic meters. The third is the Vyakarana, which explains grammar. The fourth, Nirukta, explains etymology, and the fifth is Kalpa, which explains the rubrics or rules for carrying out the various Vedic rituals. The sixth and final text of the Vedanga is the most important for our purposes, and is the Jyotisha, which literally translates to astronomy. After all, if you want to properly carry out the prescribed rituals, you have to do them at the right times. And how will you know what the right time is if you don't know astronomy? Well, the Jyotisha forms the culmination of Indian astronomy during the Vedic period. Around 400 BC or so, we transitioned to the Babylonian period, where Indian astronomy was heavily influenced by Babylonian astronomers to the west. 2 centuries later, developments from Greece start to make their way into India, and 200 BC to 400 AD is characterized as the Greco-Babylonian period. Then, around 400 AD onward, the Babylonian influence starts to wane, and this period is simply known as the Greek period of Indian astronomy. Now, as we'll learn when we get to these periods, Indian astronomers during the Babylonian or Greek periods were by no means just parroting the ideas developed in the West. They made substantial discoveries of their own. But when you're characterizing centuries of history, it's useful to identify new influences when you're marking periods. In the history of architecture, for instance, we talk about the Romanesque period during the Middle Ages, not because medieval architects were copying Roman forms wholesale, but because this period was characterized by a stronger influence from earlier Roman architecture. Well, the Greek period lasts until perhaps 1500 or 1600 AD, at which point it fades into the Islamic period. Finally, starting around 1800 or so, as British dominance over the subcontinent had become entrenched, the astronomy transitions to the modern period, eventually producing one of the greatest astronomers of history, Subramanian Chandrasekhar. But the story of Indian astronomy during the Islamic period and modern period will have to wait until much later in this podcast. In the next episode, we'll move into the second and more substantial half of astronomy during the Vedic period and look at the Jyotisha. But before I leave you for next month, I wanted to end with a brief overview of the historiography of Indian astronomy, how it is that we have come to know what we know about it in the West. Now, of course, thanks to the continuity of the practice of Hinduism since ancient times, knowledge of Vedic astronomy was never forgotten in the same way that, say, Egyptian astronomy or Babylonian astronomy was. But none of this was known in Europe until the 17th century, when the first contacts between India and Europeans began. In the late 17th century, a French diplomat by the name of Simon de la Loubère traveled to Siam, which is modern-day Thailand. De la Loubère arrived in October of 1687, and despite the long journey to get there, stayed for only 3 months, leaving in January of 1688. In that time, he was given a tour by the Siamese diplomat Okun Chamnan, who knew Portuguese from an earlier attempt to travel to Portugal as an envoy. During his stay, de la Loubère was given a variety of presents, and among these was a document which came to be known as the Siamese manuscript. Now, although he didn't understand exactly what this document was about, de la Loubère was something of a mathematician and recognized that the document seemed to be of a mathematical character. So when he arrived home in France, he passed the document along to Gian Domenico Cassini, who had a reputation for being one of the greatest astronomers in France at that time. The manuscript contained a number of rules and tables, and after deciphering the number system, Cassini was able to figure out from the patterns in the numbers involved that the tables had to do with predicting the positions of the sun and the moon. But as he was analyzing these predictions, he noticed something of a curiosity. The predictions were 3 arc minutes too large for the position of the sun, and 40 arc minutes too large for the position of the moon. But he noticed that they would both be correct if the tables had been prepared 18 degrees west of Siam. From this, Cassini concluded that this manuscript was not about Siamese astronomy at all, but was actually the first document about Indian astronomy that had made it to Europe, and was the first indication to Europeans that Indians had already developed a sophisticated astronomy. The next big leap in the West's understanding of Indian astronomy came almost a century later, during the transit of Venus in 1761. Now, when the time comes, I'm going to spend a good deal of time on this event because it was one of the most important things to happen in all of astronomy. But for now, it will have to suffice to say that European astronomers were extremely interested in observing this transit from all across the globe, since it was one of the only ways that they could get reliable measurements on the size of the solar system. And as a consequence, astronomers spread far and wide in anticipation of this event. One of these astronomers was a man named Guillaume de Gentil, who volunteered to travel to India and make an observation there. Unfortunately, this was during the 7 Years' War between France and England, which made this kind of a long journey difficult. After 4 months of travel, he arrived at Île-de-France, or modern-day Mauritius, to the east of Madagascar. His ultimate destination was on the southeast coast of India, at the city of Pondicherry, which the French controlled at the time. But British control of the Indian Ocean made travel difficult, so he was obligated to stay in Île-de-France for about 9 months. At last, with about 3 months to spare, he was able to find passage to Pondicherry, which would get him there a few weeks in advance of the transit. But, sadly for the hapless Le Gentil, by the time he arrived, it had turned out that the British had captured Pondicherry, and the ship was obliged to turn around and go back. When the transit occurred, he was still at sea and was unable to make the observation. Now, the thing about transits of Venus is that you get a second chance. They come in pairs, 8 years apart. So Le Gentil thought, no problem, I've already come this far, I'll just stay for the next one. So he spent the next 8 years traveling around the Indian Ocean and arrived in Pondicherry well in advance of the second transit. He constructed a small observatory, but on the day of the transit it was cloudy in Pondicherry and he observed nothing. After all this, he headed back home to France, but again, with the difficulty of travel, this took him more than 2 years. By the time he arrived home, he discovered that none of the letters he had sent in the intervening 12 years had made it to their destination, and that he had been declared legally dead. His wife had remarried, and his family had divided his property among them. But Le Gentil's travails were not quite for nothing. During his stay in the south of India, he observed a lunar eclipse with a local Tamil astronomer. The Tamil astronomer had used Indian techniques to predict the duration of the eclipse, and the observation had revealed that his prediction was too short by about 41 seconds. By contrast, Le Gentil's own tables, which had been prepared by the German Tobias Meyer, were too short by 68 seconds. Le Gentil was extremely impressed by the superior accuracy of the Indian predictions over the European ones, and this led to much more interest in Indian astronomy in Europe when he returned. 16 years later, in 1787, the Frenchman Jean-Sylvain Bailly wrote a book on the subject of Indian astronomy. Those of you who are fans of the French Revolution may recognize that name because history better remembers Bailly as the man who presided over the tennis court oath, which is typically marked as the start of the French Revolution. But, as with many of the early proponents of the Revolution, Bailly lost his head during the Reign of Terror. But his book on Indian astronomy was read across the Channel, and as England consolidated its rule over India during the 19th century, it inspired British scholars to decipher the Jyotisha and understand how Indian astronomy worked. So, I think I will end things here for this month. Next month we will pick up with the Jyotisha and learn about the height of Vedic astronomy. I hope you'll join me then. Until the next full moon, good night and clear skies.